All right, guys, open up chapter 20. All good, ready? Shall we? All right, guys, let's go. Let's look at chapter 20. Okay, so guys, for your info, this is when your honeymoon begins. Yeah. Chapter 20, chapter 21 is very, very honeymoon. Very easy chapter. All right, first, let's look at delta H lattice. So again, delta H lattice, right, is when we are forming an ionic solid from an ions, energy is released. Yeah. So it's an exothermic reaction. So I can say that, right? The definition is the energy released. Okay, when 1 mole of ionic compound is formed from its gaseous ion. Under standard condition. Okay, so energy release, 1 mole of ionic compound is formed from its gaseous ion. Please remember that. All right, guys, next. It is always exothermic combining your ions. I remember that. Okay, and lattice energy is always negative because value of delta H is always exothermic. Okay, so the more, highlight the word, the more exothermic the value is, the stronger the ionic compound. Done? All right, guys, next. What are the factors affecting the value of lattice energy, right? You have two factors. The first one, right, is your ion size. Second one, we call it as nuclear charge. All right, guys, now let's look at my study tips. All right, guys, first part, I want you guys to prioritize, okay, the charges first before looking at the size of the ion. Okay, so guys, I can say, right, the greater the effective nuclear charge, so the higher okay, so the higher the effective nuclear charge, the more exothermic your delta H lattice are. Okay, so which is why, right, guys, if you look at Mg, it's definitely greater than your Mg is definitely greater than your Na, okay? Or your O2 minus is definitely greater than your F minus. And All right, guys, second factor, ion size. Kid, the bigger the ion size, how? The more or the less negative? The less negative is your delta H ladder. Done. Okay, because again, right, if you have a big ion, how? Okay, you have a big ion, what happened to the attraction? Is the attraction here strong or weak? Weak, right? Which means a weak ionic bond is formed, right? So which means it's easier. Okay, finish up. Give me a minute. I go washroom and water. Go, go, go. Give you guys about 1 minute break, 2 minutes break. Go. Hey, let's go. Oh my God, I put my screen. How? All right, guys, let's go. Okay, you see? Okay, as the size of the ion increases, what happened to the lattice energy? Go. The lattice energy become? Okay, so again, guys, I don't want you guys to use the word increase or decrease. So try not to write increases and decreases here. I do not want it to be. Okay, because guys, again, negative 300 to negative 100, increase or decrease? You tell me now. Increase or decrease? Some people say increase. You are right, right? Okay, some people say decrease. Also, you are right. So again, guys, examiner will not mark because they do not know. Are you telling about the magnitude decreases or the overall value increases? So try not to write increase and decrease here, but to write it as more negative, less negative, more exo, less exo. So I want you guys to write it as less exothermic. Don't write increase and decrease. No. Okay, because the value has a sign, a negative sign. So don't write increase and decrease. So guys, again, I can say that the charge density decreases with the increasing ionic radius. Okay, why charge density decrease? Again, as you go across, okay, you see, if you have a bigger and bigger ionic radius, what happened to the charge density? What is charge density again? Should you remember what charge density is? It's the charge over the size, right? Do you see that? -1, -1, -1. Everything is -1. But look at the size. Do you see that the size is bigger? So when the denominator is bigger, the charge density decreases, right? Get it? Can I? Come again, bigger ion. Okay, again, if you have a bigger ion, what will happen to the bond form? For example, I minus bond with CS plus. Is it weak bond or strong bond? Weaker, right? Because the attraction is weaker, right? Get it? Why? Yeah, it's far away from the nucleus, right? All right. So which is why when the attraction is weaker, then less exothermic. Understand? Or you see, the more exothermic it is, the stronger the bond, the stronger the ionic compound. So if you put a small one, you see that the attraction is very strong. All right. So you have a high value or more negative value. But if you have a big one, you see a weaker attraction, which means less exothermic. No? Because the bond is weaker. When a weak bond is formed, less energy is given out. When a strong bond is formed, a lot of energy is given out. All right, bond form, release energy. No, bond break is absorb energy. If you want to break a bond, absorbing energy. Break a bond, absorb, forms a bond, release. All right, guys, next. Charge on the ions. So, guys, the lattice energy becomes, you guys tell me the answer, as the ionic charge decreases. You have to tell me why also. Go. How? Cannot say decrease, increase. Why more negative? Okay, so again, to answer your question, ionic charge decreases, which means from 2 plus turn into 1 plus. So guys, what will happen to the ionic bond? Is it weaker or stronger? Weaker, right? When you have weaker ionic bond, more energy or less energy release? When you have less energy release, more exo or less exo? Thank you very much. Get it now. Don't memorize, try to understand it, yeah? Clear. Lovely. Sure. So again, you see, the value of MgO is way higher. LIF is 1000 plus, MgO is 4000 plus. You see, they have similar radius, similar size. Just that Mg2 plus and O2 minus attract each other more strongly. Why? Because high charge, right? So stronger bond is formed. Oh my God. Sorry, my bad. Too hungry. Where's my food? All right, guys, next. We have ion polarization. Oh, Lawrence, what is this nonsense? Okay, so for ions polarization, right? Guys, you done ion polarization, you done it in school, right? Okay, so ion polarization, again, it contributes to covalency. Which means, right, guys, when ion polarization occurs, you have some small extent of covalent bonding, of covalent property is shown. Understand? Okay, so it contributes to a covalency. So when ion polarization occur, okay, you see some covalent effect. Okay, some covalent property. All right, guys, in some cases, the positive charge on the cation will attract the electrons from the anion. Okay, so again, don't care, guys, I'll give you a diagram. So, kid, you see, right, this is the difference between an ideal case and in actual. So, guys, in ideal case, right, okay, last time when we done it in IGCSE and A levels, right, AS, right. So, example, if I put Al3 plus like that, and O2 minus next to it, right? So I can visualize them as Al3 plus and O2 minus. So if you put it side by side, right? Okay, you have thought that they arrange like that. Okay, so, but this is not the case. Okay, so this is not the actual case. In actual case, right, it's not like that. So in actual case, right, you draw it out first, later I'll show you how it look like in actual. All right, guys, in actual, okay, it's not gonna be like that now. Okay, so I want you guys to draw your Al3 plus. Okay, and O2 minus, right? When you put it side by side to your good. When you put it side by side to your Al3 plus, right, guys, your O2 minus, okay, the electrons cloud in your O2 minus, right, will get dragged into the OH, into the O2 minus. Okay, so they will get dragged like that. So basically, they get dragged inside, and it does look something like that. So when this thing occur, right, this we call it as ion polarization. Okay, when this thing occur, we call it as ion polarization occur. Okay, when your cation is very small, okay, and having a very high charge, okay, and your anion is very big and is easily disrupted. So this we call it as ion polarization. Okay, don't worry, come, let me talk about it. So in order for ion polarization to occur, right, my cation, okay, must have a strong polarizing ability, understand? So to have a strong polarizing ability means the ability to pull the n electron cloud. Okay, to pull the n ion electron cloud, that we call it as polarizing ability. So in order for them to have strong polarizing ability, their ionic radius must be small or big. So for example, if you put a fat dude here compared to a skinny dude, which one is having a stronger polarizing ability? Smaller one, right? Because it's closer to the nucleus, right? So you must have a small ionic radius, understand? Okay, next, let's look at the charge. Do you prefer it to be 1 plus or 3 plus? In order for you to pull it, do you prefer to be 1 plus or 3 plus? Yes, correct. Second one must be high charge. All right, guys, next. All right, guys, next. Okay, let's look at your anion. So again, in order for your anion to be easily polarized, easy chapter. So again, I can say, right, the bigger the anion, then the easier it is to be polarized, right? Correct. All right, guys. Okay, so which means the electron cloud. Okay, so the electron cloud is distorted. Okay. Okay, electron cloud is distorted. So this is also known as a polarized anion. So guys, when anion is being polarized, right, the bond in the anion is weakened. Okay, so the bond in anion is weakened. That's it. Polarized means being pulled. Okay, polarized means pull. Nah, you don't need to define that. The definition is out of the syllabus.
Should I go to
Go back. Go home tonight.
Go home then go outside.
Go out somewhere. Where? Go out. All right, guys. In some cases, the positive charge on the cation will attract the electrons from the anion. So this result in the polarization of the anion electron cloud. Okay, the ability of the cation to pull the electrons towards itself is known as the polarizing power. Done. Electron cloud, this one, electron shower. Pull. Distorted means pull. The second, let me see my grapefruit. Yeah. Give me a minute, very quick, guys. Next page, please. Give me a second. Let me drop a call. Hey, guys, next page.
No, that's English.
Hey. All right, guys. Now, what is electron affinity? What electron affinity is? So guys, electron affinity, right? We call it as the ability to receive electrons. Yeah. So it's just opposite of ionization energy. Okay, so guys, the first electron affinity, right, is the enthalpy change. When 1 mole of gaseous atom, okay, receives 1 mole of electron. Remember, yeah? Okay, to form 1 mole of gaseous 1 minus ion. Just spend your glasses, right?
Oh, yeah, shit.
Oh my god, later you forget again. Oh, like last time.
What?
No, I mean like you spend an hour to travel here for a 15 minutes lesson.
No, I was in 1 year with him. 10 minutes.
Oh. Hey guys, next.
This one have too much calorie, man.
I did not mean prep today. So guys, you see that from gaseous, receive 1 electron, also into gaseous. Gaseous to gaseous. And guys, let's look at the value. I want you guys to write it down. Your first electron affinity is always exothermic. Yeah? This chapter is the easiest. So, okay, remember, yeah, guys, first EA is exothermic. All right, guys, next, highlight this second EA, highlight plus, and write it down as second EA onwards. It's gonna be endothermic now. Okay, guys, remember second EA onwards is endothermic. Yeah? You guys done right? Why? What's the reason? What's the reason?
Oh,
Why is it endothermic for second EA? Yes. How? Alright, guys, second EA are endothermic. What's the reason, guys? Okay, because you are adding electrons into an anion, right? Anion is already negatively charged, right?
well,
It repel each other, am I right? So it will repel one another. So I can say that. What the hell? So guys, you see, right? Let's say if you want to add 1 more electron in, right? To turn it into a Cl2 minus, yeah. This is your second EA, right? Do you see that negative charge anion and negative electrons, they will repel one another. Understand? So they repel one another, which make it, okay, require energy to overcome the repulsive forces. Cook zero. So not healthy, right?
you believe in that shit, man?
I mean, that's the
zero
only
means 0 calories.
that's the only that's the only soft drink I think. Oh my god.
Oh, 0 calories, man.
Zero sugar ma. They say
That's bullshit, bro. 0 sugar, my ass.
Okay, so guys, highlight energy is required to overcome the repulsive forces between anion and incoming electrons. Highlight this part, guys. Going down group 17. Okay, electrons affinity becomes less exothermic down the group. Guys, again, avoid using the word increase or decrease. Yeah, use more exo or less exo. Why? Reason being, atomic radius increases down the group. Attraction is weaker now. Done. Haber cycle, yeah, guys. So, guys, for a bond Haber cycle, right, it's basically a type of energy cycle used to calculate your lattice energy. Chapter 20. All right, guys, now, okay, so for your bond Haber diagram, right? Okay, so guys, I want you guys to put it down. So whenever you are drawing an exothermic progress, yeah, okay, any reaction that's exothermic, right? Okay, arrow always go down. Guys, but okay, page 6. But when you have any endothermic reaction, your arrows always go up. All right, guys, you see, right? To construct your bond Haber diagram, yeah. First, what I want you guys to do, right? I want you guys to draw a ground state. And after that, state the product. All right, then, guys, for your second step, right? What I want you guys to do, please form our delta H lattice on the right hand side. And your delta H, okay, formation on the left hand side. The step. Last week, yeah. No. I don't see any Tutor. I just saw him alone. Maybe she was downstairs or something. All right, guys, connect your delta H formation, okay, to delta H lattice. Okay, you guys need to connect your delta H formation to your delta H lattice, and guys, label all the delta H. Fourth step, clockwise equals to anti-clockwise. Okay. All right, guys, now. What do you mean clockwise, anti-clockwise? Later I'll show you, don't worry. Okay, there's one thing that you need to. Where's Chantal? Where's Chantal? Skipping up. 我见男朋友. Okay, guys, again. Okay, I want you guys to write it here to relate our bond energy. How's party today? To delta H atomization. It's okay lah, I don't care also. No, she never. Okay, so guys, let's look at your, okay, how Chantal, Chantal is here. Teacher, I have insufficient permission to download the file. Huh? You can download the file. All right, guys, next. You see, kid, let's say, right, if I have 1 mole of chlorine gas, okay, so you see I have 1 mole of chlorine gas, Cl. And guys, if I break it down, right, what do I get? I get 2 Cl gas, correct? So this value that we have, right, this is bond energy. Understand? All right, guys, now, okay, how do you convert your bond energy to delta H atomization? Remember, yeah, your delta H atomization, right, always stand for 1 mole of atom form. So guys, do you see that this is 2 mole of atom? So this entire equation, go and divide it by 2. So you get half Cl turn into 1 Cl atom. Okay, this value, we take bond energy divided by 2. That is your delta H atomization. So guys, you know the difference between atomization and bond energy? Bond energy is you're breaking a mole of molecule, 1 mole of molecule. Atomization, you are forming 1 mole of product. You are forming 1 mole of atom. Clear? So guys, to relate your atomization to bond energy, put it here. Atomization is always half the bond energy. All right, guys, once done, next page. All right, given that, right, delta H atom of sodium is 107. Okay, first ionization energy of Na is 494. Then Ea of Cl is -349. Formation is -441. Bond energy is this much. And I want you guys to calculate the lattice energy of NaCl. Okay, so a minute. I'll wait for the 2 kids to come back, then I'll continue. You guys can read the question first. Second, guys, we're starting soon. Sorry. All right, good. All right, guys, first, what I want you guys to do, right? That's okay. About what?
About Johnny.
All right, guys, first, okay, I want you guys to draw a baseline. Okay, draw a line at the bottom and label your product. What are we forming? Sodium chloride. Okay, that's your first step, yeah, guys. I'll slowly guide you on drawing your bond Haber cycle. All right, guys, after drawing your ground state, right, second step, please form lattice energy on the right, formation on the left. Lattice energy about, okay, on your right. Okay, so this is delta H lat. All right, guys, should remember what is lattice energy. Lattice energy is from a gaseous ion combined into a ionic solid, right? So gaseous ion combine NaCl. Okay, delta H lattice on your right hand side. All right, guys, what about your left hand side? What do we put? Left hand side is your delta H formation, right? Again, your left hand side, that's your delta H formation. So guys, left hand side. And guys, how to form? So to draw your formation, right, it's always okay. You have to get, for example, right, I need NaCl. Definitely, I need 1 mole of sodium, and sodium under standard condition is solid state. And guys, where do we get Cl from? We get Cl from a chlorine gas, and under standard condition is a gas. Okay, and I can put a half here. All right, guys, next. Right now, let's look at sodium. Okay, how do you turn sodium solid into sodium gas plus? So first step, right, guys, I need to atomize our sodium first. Up. All right, guys, solid sodium turn into a gas sodium, yeah. So that is your delta H atomization of Na. Understand? So guys, you have to slowly convert, yeah. This I have to slowly convert it here. So sodium, I convert the state first. Now you see sodium gas, sodium gas. All right, guys, you have to convert it by adding a charge. How do you turn sodium into sodium plus? What's the process? Na to Na plus is a first ionization energy, right? So right now Na plus, correct? So guys, do you see that Na plus? Na plus is the same already. Good. Right now, I just have to turn my half Cl2 into Cl minus. Okay, nice. Guys, I can turn my half Cl2 into a Cl atom first. Huh? This still Na plus gas, Cl gas. Okay, so this is my, what is this? First IE, and this is your delta H atomization of Cl, right?
What's the main theory?
All right, guys, next. Okay, from Cl gas to Cl minus, what is the process? This process is first electron affinity, right? That's it, guys. Okay, now your entire diagram is completed. Alright, guys, now I want you guys to plug in the value. What is my value? Atomization is 107. Plug it in. First IE is 494. Electron affinity is a negative. Arrow goes down already. Negative 349. Formation of NaCl, negative 441. Okay, next. Bond energy of Cl. So, guys, how to turn bond energy into atomization? So, guys, this is atomization. So, atomization is half times your bond energy, right? Half times 242. And this is my lattice energy, which is an X.
Các bạn bảo là
Okay. Okay, guys, once done. Okay, the last step is clockwise equals to anti-clockwise, right? Guys, where's my clockwise arrow? You see, all these arrow can be combined, right? These are your clockwise arrow. Can I see that? Can you see that? So these are your clockwise arrow, right? One more time. Clockwise arrow, right? You can see that. You can combine everything, right? So everything here is a clockwise arrow. Where's my anti-clockwise arrow? It's only this way. So this is my anti-clockwise arrow. Good. All right, guys. Now, can you apply clockwise equals to anti-clockwise? Find out X. Go. So, guys, can I say that 107 plus 494 plus half multiplied by 242 plus negative 349 plus X equals to what? Negative 441. Guys, find out the value of X. Go, go, go. What's your answer, guys? Negative 814, right? You guys get the answer? Done. All right, guys. What's that next question? Go. All right, guys, now note that arrow always going, okay, arrow going up always represent an endothermic. Arrow going down always represent an exothermic. Yeah. Okay, guys, go. So find the first electron affinity for chlorine. Go. Look at this question. I want you guys to find the first electron affinity for chlorine. Get me the answer now. Guys, let's draw the diagram. Now. Let's go. Draw the diagram. Huh? Hey, GG.
Sure.
Yeah, baby.
Two factors that are responsible for the increase in the first 6 ionization energies.
Shielding effect, nuclear charge. Let's go draw now. Hey, let me mark attendance now, guys. Okay, let's continue. Go. Do it now. Guys, put your MgCl2 at the bottom first as the product.
No, it's not. You're gonna be anti-missing. Yeah, just show me the sense. Yes. But it's my phone so bad.
Chloe is here.
I think it's a no, it's like
Really?
that's what you want. That's what you want.
Alright, guys, what's your answer? Any answer?
Sure.
Why am I a puppy?
Do you think Mr. Chin was a puppy?
You guys are.
Puppy bad.
It's bad. You're gonna be tiger.
nearing 30, bro.
Exactly, bro. Who called me fat?
You don't.
Alright, guys, let's go. MgCl2. Any answer? No answer? So one side is gonna be delta H lattice, right? Okay, and delta H lattice is always from gaseous ion. So Mg2 plus gas, 2Cl minus gas, correct. And lattice energy is negative 2526. Next. So this is delta H formation next. So for delta H formation, I have magnesium solid plus a chlorine gas. As for formation, MgCl2 is negative 641. All right, guys, first step done. Second step, you have to slowly combine, slowly connect them. Okay, go. So from magnesium, solid turn into a magnesium gas first. What is this? That is the delta H atomization of Mg, right? Correct. Value. 148, right? All right, guys, after that.
It's so mean to me.
All right, guys, next. Mg turns into a Mg plus, right? So this is your first IE, right? Then guys, how do you turn Mg plus to Mg2 plus? Your first IE value is 738, right? Put it down. Next, what else? Mg plus turns into N. Well done. My second IE is 1451. Done. Okay. Okay, guys, now my Mg2 plus done converting. How do you convert Cl2 into 2Cl minus? Guys, I have to atomize it first, right? I have to turn it into a Cl atom first, correct? So how many Cl atom we are getting? 2, right? Am I right? Guys, atomization is producing 1 mole. So since it's 2, it's going to be 2 times atomization, yeah? Two multiplied by 122, right? Alright, guys, finally, Cl turned into a Cl minus. What's your answer? So, guys, this would be your electronic affinity times how much? Times 2. Why? Because 2 mole of Cl turned into a 2 mole of Cl minus. So 2 molecule of electrons, 2 mole of electrons needed. Go. Okay, guys, after labeling all the values, please find out what is my value for EA. Now, value for EA? Here, do we have to write electrons in the hash cycle? No, it's okay. You don't need to. How much is it? Negative 348. Well done.
My God, you look like a big sport for a living.
Thank you. What? No, wait, no. No, that's not a compliment.
No, I feel like it's a compliment.
64148 plus 738 plus 1451.
Sorry.
Nosy beach.
Sorry.
Okay, I'll tell you.
Oh, you're gonna tell John there.
This is my friend.
Pronunciate.
All right, guys, what's your 2x?
No, she's not gonna say anything bad. What can she say bad? She can say good.
2x equals 696, right?
What is she? You have a lot.
Check your answer, guys. Let's go. What's the next page? I go washroom, I'll be back. Next page, I'll go.
What did he say to you? Then is that you're super sad. And I'm like,
Isn't it breaking his heart? And so here's one of them has to do something. But he's done it.
Of course, he is like super.
The one that's
Well, that's not like okay, what's that? But no, my friend was fairly my friend.
Let's go. Let's go. Hey, Dana, got this answer?
Why must those kids try jeans and go lah? First gonna get a girl with a brain jeans. You want to go again? Is it?
no.
All right, guys, now I want you guys to skip everything. Shh. Page 21.
What you got is stubborn.
but we went after her, then she's like, stupid shit. As we leave, and you know, there's always the guy, right? That's standing outside. Then he looks at her. Yeah.
But it's to him.
But it looks like stupid.
All right, now we have delta H solution, guys. Let's go. Look at delta H solution, kid, everyone. All right, guys. When an ionic solid dissolve in water, okay, the crystal lattice break up and the ions separate. Okay, so it requires a lot of energy to overcome the forces here. So now let's look at the definition. So the definition, we call it as enthalpy change. When 1 mole of ionic compound dissolve in sufficient water, okay, to form a very dilute solution. Let's go. Okay, so 1 mole of ionic compound dissolve in sufficient water. Keyword. Form a very dilute solution.
No, I see my mom keep calling me, I'm not going to do it.
Okay, example from solid turns into an aqueous, can see that. Okay, so this can be understood as NaCl turn into a Na plus aqueous and Cl minus aqueous also.
It's kind of more than this. So you don't get them. I hope that go because you like
Okay. Okay, guys, now let's look at a delta solution, right? So, guys, your delta H solution can either be a positive or negative. Okay, guys, now write down a delta H solution. If it's a negative, it's soluble. Most likely to be soluble when delta H solution is negative. And for insoluble substances, your delta H is most likely to be positive. Can. Is there a reason behind this? No. Unfortunately, no. Okay, so guys, I want you guys to put it here, delta H solution. Okay, if you see a positive value, it's insoluble, yeah. Okay, this is only valid, right, at a specific temperature. Kumi to say, isn't substance with positive are relatively insoluble? Yeah. Positive value insoluble. Correct? Yeah. Insoluble, positive what?
Thin, right? Dose is thin, right? Yeah, never mind.
Wait, what do you mean by I flip it? Yes. The hell? Insoluble delta H. The compound is soluble is wait. Insoluble delta H value or positive delta. What? No. Okay, I don't get it. Insoluble delta H value or positive delta H value.
I think because you put insoluble H delta H instead of positive delta H.
Okay. I get it now. Okay, yeah. So here, right, positive value, it's insoluble, right? My bad.
Wow.
Thanks. I just see. No, I don't get it. Yes. Huh? Someone?
So disgusting. Is that the name, Mr. Chin?
Bro, I don't shit outside. I have like a golden ass. I don't shit outside. Yeah. I have never shat in any public toilet. No, I did. The squatting one. Yeah. I cannot stand, bro. Can you imagine there's like million people sat on a toilet bowl before? Can you imagine? You think wipe the seat will help bacteria is still there? Yeah.
For my ass matches.
Yes.
Sure. You need water.
Yeah, I've seen that golden ass.
Yes.
Okay, guys, done. Next. All right, guys, this is the last part already. Go. Faster. Come. All right, guys, finally, we have delta H hydration. Yeah. Ain't not done. Faster lah.
Your head very big, right?
That's something
That's right.
Be like that. He always call me some weird ass name.
Who?
You.
Done.
Oh, biggest scale ball. Dave.
All right, guys, now let's look at hydration.
Yeah.
Okay, come. Okay, guys, for the value of hydration, right, the definition is, okay, the enthalpy change, a second. Okay, it's the enthalpy change when 1 mole of gaseous ion this time. Okay, when 1 mole of gaseous ion, page 22. 1 mole of gaseous ion dissolve. So fun.
This pants is super bad.
Okay, dissolve in sufficient water. Shukiki. Why is he wet?
Step on the water.
Why is he wet?
Got shit, right? I use my socks and run.
Oh, use your wet socks touch me for what? What the hell? Eee.
No, I wear the slipper. I wear the slipper to go through.
Oh my god.
God.
Okay, insufficient water to form a very dilute solution. Your friend lah. What is this lah? Alright, keyword 1 mole of gaseous ion.
She replied, what do you wish that was first?
Alright, example, guys. You see, from a sodium gas turns into a sodium aqueous. From a Cl minus gas turn into a Cl minus aqueous. Things like that. So these are delta H hydration. And guys, for delta H hydration is always exothermic.
Your mom telling me that to say that, or what?
Formation of
Did that
insoluble
woman
salt.
say that, right?
Barium sulfate is insoluble.
Oh, I feel like your dad wouldn't can.
Alright, done. Alright, guys, you see. Okay, here's the definite. Okay, example, right, guys. Okay, I want you guys to label it for me. Let's say if I have Na plus, right, and plus Cl minus, it turns into NaCl solid. Guys, can anyone tell me what is this?
That's a good thought.
Okay, Na plus Cl minus turn into NaCl. Guys, what is this energy? Gaseous ion turn into a solid. It's a lattice, right? Alright, guys, let's say it turns into, okay, bro, why got equals here? Gas here, bro. Okay, guys, let's say, right, from NaCl solid turns into NaCl aqueous, or your Na plus aqueous and Cl minus aqueous. What this reaction is gonna be? From solid turns into aqueous, is dissolving, right? So we call it as delta H solution. Understand? What about from gas turns into aqueous? From gas turn into aqueous, that we call it as hydration. Understand? Yeah. All right, guys, thanks. Okay, so according to this reaction, right, can you see that lattice plus solution equals to hydration? So guys, to rewrite in terms of solution, right, we can say that it's delta H hydration minus of delta H lattice. Okay, this is the formula that we use here in group 5, in group 2, chapter 25. Write it down, guys.